Question one on exact differential equation. We've used the next previous video for in-depth understanding as an intro uh, to exact differential. Okay, the first video is just like intro uh, to different as the foundation is laid in video one for exact differential. So now we're going to look at our questions. Question one. Look at what we have here. Solve this. Okay, you can see your dx, you can see your dy. Okay, so this one take the form of, you can call this one, definitely this is your m, which is a function of what? This one and this one. And you can see the what? Dx. This one is what? N. The functions of, okay, but in this case we have one function. Okay, then you can see your dy. So this conforms to the general standard that this plus this must equal to what? Must equal to 0. So it conforms to that. So the next thing is to now take the m and differentiate that partially with respect to y. Okay? Do this. And when you are differentiating partially, it's very simple. You are only looking for that variable to differentiate. I'm looking for y alone, and this is my y. And if I differentiate y here, it will become 1. I'll just have 2. This one is a constant. I'm only differentiating y. Okay? Can we also do for the n also? Respect to this function n respect to x. Okay? If you do that, and we are lucky here, this is just one function we have here. So it's what? It's 2x. So the two equation is what? I mean the two expression or the two functions are exact. This is exact. This is exact. Okay? This is exact. This is exact. Okay? And if there is exact, what do we do next? Then we can say this symbol means there is a function f of y, okay, such that delta f partial differential of f respect to x is equal to what? Is equal to what's that? Delta f respect to x. If you look at the intro, that's your m. That is what? That is m. Okay, for that one, m. Okay, and that was it has a value of 2xy. 2xy. That's the value of 2xy. Okay, yeah, because we said that there's a function in the intro, say there's function f of xy. Okay, the total differential is what? Total differential is uh, the total differential is equal to delta f, delta what? Delta x dx plus what? Delta f, delta y, um, and the y equal to 0. So this one is what we call the m, this is what we call the n. Okay, so the next thing to do now, look at your function, partial differential with respect to x. That means you integrate both sides, then you have f equal to what? Integral of m, which is at 2xy. Okay, then the what? The x. It doesn't matter whether you put the x or you put delta x. Okay, then because you are integrating respect to x partially, then this will be equal to what? Plus g of what? G of y. Okay, so in this integration now, you are only looking for x variable and integrate that one alone. This is a partial integration. Okay, so this will now become, I'm only integrating this one, which is equal to 2x squared over 2y. So these two will go, then I have what? I have g of y. Okay, so I'm having f equal to x squared y plus g of y. So the next thing to do now is to what? Differentiate, partially with respect to y. Differentiate partially with respect to y. So I will now have delta f, delta y, and delta f, delta y is our n. Okay, and it has a value in the given problem. The value is what? S squared. The value is value is x squared minus 1, x squared minus 1 equal to, don't forget that we are differentiating partially this one, okay, equal to d what? d respect to y of this one, okay, and then plus what? G prime of what? And that will give me 2x 2x give me 2xy plus g prime of. Yeah, from here now, if you differentiate partially this function, I've told you, you only look for, since it's respect to y, just look for y. You're only differentiating y, and that will be equal to, if you differentiate y here, that will be 1, then you have s squared here, plus g prime of y equal to what? S squared minus 1. Okay, and don't forget that your delta f, the partial differential of f respect to y, is called what? It's called n. And this is the value here. Okay, then you can see this one we cancel out. So I now have now g prime of y equal to what? Equal to minus 1. Okay, then you can now integrate this. If you integrate this, then you have what? Respect to y, you have g of y equal to what? Equal to integral of minus 1, which is that this is what? Integral of minus 1 respect to y. Okay, and that will be equal to what? Minus y plus c. You can call this one c1 minus c4. We've gotten the g of y. So the next thing to do now is to go back to here. Okay, is go back to here and substitute your g of y. So f is equal to what? F is equal to s squared y plus what? Plus what do you have there? We have minus y plus just substitute that, and that will be equal to what? Minus y plus c. Minus y plus cy. And don't forget that this your capital C is cos c. So that will be c equal to what? S2y minus y. Okay, plus c1. Okay. Finally, without wasting our time, let's square y minus y equals 1 equal to c. Because this c1 here can go to the other side. And there's constants minus constants. You just give it capital C, just c. So you don't need that. So just assume that this one with this one will give you this. Okay. This is more here. So that's just that, and that's the answer for our question. Okay. And another thing I want to say here is that from here, when we said the partial differential of f respect to x, we can also use another method alternatively. Alternatively, you can use delta f delta y, okay, which is equal to what? Which is equal to n. Okay, alternative, because if there is exact, this will be equal to this, and this one also will be equal to this. If there is an exact, if the equation is exact, these two functions will be equal to each other. So you can use this one also if you want to. And if you want to do that from here, what you do is just for you to integrate both sides. Then you have f equal to what? Partial integral of your n, which is your what? Your n is x squared minus 1, okay, and then delta what? Delta y for dy, okay. And in this case now, you are integrating respect to y, so your constant with what? G of what? G of x, okay. Then from here, you now have, if you integrate this respect to y, so this will be equal to s squared. This is a constant. Y is partial integration. This is constant. So if you open this bracket, to be x squared dy minus dy. So this will be this minus y plus g of what? G of x. Okay. Then the next thing to do, we want to get this g of y. Differentiate partially respect to x. So we now have delta f, delta what? Respect to x, delta x, okay, which is equal to which is equal to m, and your m has a value. Your m is what? 2xy. So now differentiate this one with respect to x, which is equal to respect to x, this will be cos times, and that we're only differentiating x squared, and that will be 2xy. Okay, then minus 1. If you differentiate this respect to x, there is no x here, so it's going to be cancelled. So we just have plus what? Plus. Yeah, we just have a plus what? Plus g prime of x. Okay, then we have a value for m. Our m is what? Our m is 2. Our m is 2xy equal to 2xy plus g prime of x. So this one will cancel out. This one will cancel out. Okay, this one will cancel out. This one will cancel out. Then you have what? You have g prime of x equal to g prime of x equal to 0, and if you integrate both sides, g of x equal to 0, then just come back to this place and substitute that, and you can see you get the same answer as we did for the other one. Okay, this one is 0. Okay, you just have this one equal to c. Whichever way that suits you, whether using partial differential of f respect to x or using partial differential of f respect to y, just choose the one that convenient for you. The two ways will lead you to the same answer, and that's that on that. Okay, that's that.